This presentation discusses the optimization of a turbine blade's cooling capabilities and the defect mitigation involving the additive manufacturing process of the turbine blade. This project is led by Dr. Akiva Wernick, the principal investigator, and Andrew O'Reilly, the project leader, and assisted by Dr. Mark Johnson. Our company, Cornerstone Research Group, is a leading aerospace and defense firm based near Dayton, Ohio. Our mission is to advance national security with cutting-edge technology solutions, and our vision is to become a premier aerospace and defense company here in the United States. Here at CRG, we have competencies in a variety of sectors. CRG has performed work in the design and maintenance of aerospace systems, development of sensors and AI systems to improve human health, innovated ways to produce, store, and distribute power and energy, designed advanced materials, and innovated the design process for additive manufacturing, and provide integrated capabilities for multiple engineering problems. This presentation focuses on our LATASolve technology, which falls under our advanced materials and manufacturing capabilities. CRG grew 411% between the years of 2018 and 2023. We have over 63 partners for which we have invested over $10 million. CRG has 117 patents issued or pending, and 180 employees with over $18.8 million in wages as of 2023. CRG has invested over $250 million in non-SBIR investments and over $2 million in Phase 3s per Phase 2 SBIRs, which is 8 times the 2024 benchmark requirement. The challenge presented by the Office of Naval Research for this project was to optimize the design of the lattice structure and cooling passages for a turbine blade to improve its cooling capabilities. Additionally, the optimized turbine geometry should be capable of being manufactured using advanced additive manufacturing techniques. Our objective is to demonstrate the design can be manufactured using additive manufacturing technology and to develop capabilities to predict potential defects in the design process. We plan to transition the technology we develop for this program by upgrading turbine blades in existing engines and integrating the technology into future engine programs and other programs that require lattice optimization. So, what are the current operational needs, and how can our tool provide improvements? Many high-pressure turbines operate under extreme temperatures, which limit the operational lifespans of the blades. High-pressure turbine blades are critical components that, with the current designs, require frequent replacement to maintain the efficiency and reliability standards of turbine engines. Being able to improve the lifespans of the blades will drastically reduce the costs associated with replacing the components. The Office of Naval Research seeks additive manufacturing solutions that will improve the cooling pathways and lattice structure of a gas turbine blade and develop an analytical toolset that can enhance manufacturing efficiency while mitigating defects using machine learning technologies. Our LATASolve toolset can achieve these goals. LATASolve is a multi-physics-based computational toolset that optimizes the cooling capabilities and structural performance of lattice structures of complex shapes. To achieve the optimal design, LATASolve can modify the lattice beam, thicknesses, and the local wall thicknesses. LATASolve is also capable of generating internal webbing to maintain regional pressure and node migration to enable a dynamic lattice density. LATASolve is also integrated with a machine learning additive manufacturing defect prediction tool that can be used to predict and mitigate potential defects that may occur in the additive manufacturing process. The key features of LatiSolve are its ability to alter the member thicknesses of the lattice for balanced strength and cooling flow, the ability to vary the localized wall thickness to maintain strength requirements, the enabling of the addition of internal webbing within the lattice to direct flow and maintain regional pressure, and the enabling of dynamic lattice node placement to control the node density within a local region of the lattice. The optimization process provides the benefit of minimizing the structure's weight and material while providing a balance between the target strength and the cooling capabilities. A key advantage of the LatiSolve toolset is its ability to predict potential defects that may occur within the additive manufacturing process. Predicting the locations of potential defects will allow the designer to modify the design to accommodate the potential defects to reduce the defects that may occur as the product is being printed. It is intended to transition the LatiSolve technology in the subsequent Phase 2. For the transition process, CRG will investigate performing an operational test by optimizing a modern turbine blade and comparing a physical print of the optimized geometry to a physical specimen of the baseline. CRG is currently in contact with original equipment manufacturers, including General Electric and Pratt & Whitney, to obtain the physical and CAD models of a current turbine blade which we can use for the testing. Some potential markets for the LatiSolve technology include commercial use for the design involving air vehicles, power generation and microgrids, marine vessels, and land vehicles. Our commercialization strategy involves utilizing CRG subsidiaries, such as Rushlight Ventures, to transform LatiSolve into a business line and develop short and long-term commercialization opportunities. Shortly, it is intended to offer LatiSolve as a design service and transition it to licensed software, as its capabilities are improved and refined. Some potential customers include General Electric, Pratt & Whitney, and government agencies such as the Department of Defense, NASA, and the Department of Energy. The primary support needed for CRG to transition LatiSolve is obtaining the geometry files and physical specimens for testing. Ideally, the obtained geometries contain cooling holes and are a part of existing design challenges that benefit from the lattice structure and cooling optimization. CRG is also looking to extend the commercialization of LatiSolve to non-DoD opportunities. This concludes the presentation, and we thank you for your time. If you have any questions or believe that you can assist in our program, feel free to contact either Dr. Akiva Wernick or Andrew O'Reilly using the contact information listed on this slide.